Hi guys, for today's lesson we're going to be dealing with network flow problems. So some words to remember here. What exactly is a flow problem? They're problems which involve the transfer or flow of material from one point, the start called the source, to another point, the end called the sink. So it's important to remember that the source is the start and the sink is the finish. A typical flow problem is water moving from source to sink through pipes of various sizes. We'll get to those sorts of problems in a second. Next up, we need to understand what a cut is. So a cut in this context is an imaginary line through a network that separates the source and sink and only passes through edges, so it doesn't pass through any dots or any vertices. They are used to determine the maximum flow through a network. So these cuts are going to be very important for some questions that are coming up. This is an example of a cut right here. We can see this dotted line that kind of cuts up our network. It cuts it kind of in half, if that makes sense, into two parts. And it's super important that your cut is separating the source and the sink, the start and the finish. So that is definitely an example of a cut. This one over here, this is definitely cutting up our network, but it's not separating the source and sink. So we consider that to not be a cut. Okay, so moving on. So some rules to remember here, people. Consider the following networks of pipes. So this is a typical network sort of problem or a flow problem. And we want to consider the maximum flow of water that can fit through these networks of pipes that we see here. So what's the most water that we can fit through this pipe system? Well, the idea is that because this little pipe only fits 25 litres per minute, and this can fit 58 litres per minute because it's a lot thicker, if we want to force water through this pipe system, the smallest pipe determines the maximum you can fit through it. Like this pipe system will only be able to fit 25 litres per minute through it. There's no way you can get any more water through that pipe. With this one here, even though it starts off with a big pipe and it ends with a smaller pipe, again, this smaller pipe determines the maximum you can fit through the whole thing. So again, this is only going to be 25 litres per minute. So the rule is that when pipes are connected end to end, the smallest pipe determines the maximum flow. However, the maximum flow becomes more complicated when pipes branch away from each other. So don't always think, you're not always going to be looking to say what's your smallest pipe and think, yep, that's the maximum flow through the whole network. Because if your pipes are branching away from each other, suddenly it becomes you can get more flow through it because you've got multiple paths and routes that the water can take. It just doesn't have to go down one pipe. So when you are dealing with a large networks of pipes, so a lot more complicated systems, instead of looking for the smallest pipe, the rule is that you want to look for the smallest cut, and that will determine the maximum flow through the whole system. So remember, guys, you have to go back to your definition of cut if you're not sure what I mean. It's pretty much a line that's halving your entire network and separating the source and sink. So let's do some example questions. So determine the maximum flow for the following network. So we want to think, what's the maximum amount of material or water we could fit from the start to the finish? So the strategy is that you need to search for the smallest cut possible. So we want to be cutting up this network like this and finding the one that is the smallest, because that will tell us what the maximum you can fit through this network is. Okay, so remember that cuts separate the start and finish. So here in these colours, I've got 3 cuts. They've pretty much halved the network or split into 2 parts, and they're cutting off the start from the finish. So if we look at these 3 lines here, what we have to do is we need to add together each weight that the cut passes through, and that will tell us the total weight for that cut. So for example, this pink one, it's cutting 70 and 50, so that has a cut of 120. The brown cut, 45, 35 and 40, that sums up to give 120. And the green one is going to be 30 and 80, which gives a cut of 110. So if we look at these 3 numbers here, this is suggesting that the maximum you can fit through this network, the maximum flow, is going to be 110 at the moment. But we have to check all the cuts. We need to find the smallest one possible, and we've only checked 3. There's more cuts to follow, as you can see here. So more different cuts. This black one cutting there, it still cuts off the source and the sink. That's going to be a cut of 115. The red one is a cut of 105, and the purple one's a cut of 185. So here we have a new low, 105. That suggests that the most you can fit through this network is only going to be 105. Still, we need to check every single cut. There's still a few left over. We've got this blue one here. That's 110. This pink one here is 130, and this green one here is 125. And finally, that's all the cuts done. I've literally found every single possible cut that you can do that separates source and sink. And the lowest we found was cut 5, 105. So your final answer is that the smallest cut is 105, hence the maximum flow is 105. So remember, the rule of thumb is smallest cut equals max flow. That's how you find the maximum flow through a network. Determine the capacity of the shown cuts. So we've been shown cut 1, cut 2, cut 3, cut 4. We need to we're trying to figure out the value of these cuts. Now, an important note here that we're trying to practice is you only want to count edges which are moving from the source side to the sink side. You don't want to count lines or pipes which are going in the direction against that sort of flow. We want to be going from source to sink, because we want to be going from this side to this side, if that makes sense. Okay, so cut 1, let's have a look at this dotted line here. So this line here passes through a 15 and a 20, so that's going to be a total of 35. Cut 2, so cut 2, if we look at that, guys, it passes through this line, and this line, so 3 lines that it passes through. However, if you look at this line right here, this line, that arrow is going from the sink side over on the right hand side of the line to the source side. It's going from your end back to the start. So you do not want to count this 6 in your cut. It's only going to be the 20 and the 14 that's going to be counting. So it's going to be 20 plus 14, which is 34. The 6 flows from sink to source, so you don't count it. Really important that you're remembering that. Cut 3, it's going to be 14, 15, and 20, which makes 49. That's the capacity of that cut. And cut 4 is going to be the 20 because it cuts this line. It's going to be the 10, but it's not going to count this 12 because that direction is going from the sink side back to the source side. So don't count that 12 there, this 12 here. So therefore, it's just 20 plus 10, which equals 30. The 12 flows from sink to source, so again, don't count it. This suggests that the maximum flow through the network is 30, because this was the smallest number out of all these cuts that we found. We haven't checked every cut, but out of these ones, it suggests this is the lowest, so therefore, that is most likely going to be the maximum flow of just 30. Hope this helps with the questions. Good luck.